Hello! Hello, everybody! Welcome back! Welcome back! It's been a while. So, today we're going to talk about. It's a very big topic. Very, very big topic that connects so many threads. This is so important, guys. It's the phenomenal binding problem. And yes, I actually think we can solve it. And in this video, we're going to solve it, which is very exciting. And, it's never been done before in the history of philosophy. I know it's a tall order, incredibly arrogant thing to say, but here I am, very excited to talk about it, and I hope you're interested in listening to it. So, well, we're gonna start off with the Qualia of the day. This is such a difficult topic. We actually need, throw everything at the wall and just see what sticks. So, we have our friendly, ginger juice. I also got some sugar-free Red Bull. I downed a coffee just before this video. Also took a heroic dose of L-theanine, which is, one of the active components of green tea. Is mildly relaxing. Well, it's not a heroic dose. I took half a gram, which is a relatively high dose. I've taken higher. It's fine. But what else have we do we got in here? Well, the Qualia of the day is Acqua di Gio, which is a beautiful perfume. Alberto Morillas, one of the greatest perfumists of all time, made it, or was one of the contributing perfumists. This is quite incredible. I mean, it's obviously a very citrusy, very aquatic smell, and very musky. But the thing that I really love about it is that the phenomenology of it, for me, it's very cross-modal. Like, it's almost synesthetic, and the thing that stands out about it is that it feels like it's something like this. It's kind of like it's half transparent, half opaque, and I can't imagine anybody really hating it. I mean, it's really kind of like such a safe smell in a way, but it's beautifully done. Well, I'm not going to go too deep into it. Importantly, Luca Turin, who wrote Perfumes, and his wife, Tania Sanchez, the A to Z guide, I almost regard it as kind of like a, the PICAL, the phenethylamines I have known and loved of smells, of perfumes, because it's, so many reviews of so many perfumes. They're hilarious for the most part. And they review Acqua di Gio, and they say essentially it's a perfume that is only compatible if you think that, your lifestyle is compatible with white carpet. Kind of like these very 90s decorations, interior design with cubes and, instead of like portraits or anything, it's just like a plain white square type of lifestyle. That's very much this perfume. And it's I associate it a lot with mandarin and cologne. Cologne is a very important molecule responsible for the aquatic component of so many perfumes. And definitely also lime. Well, anyway, very relatedly, another incredibly safe perfume component is ambroxan. When in doubt, add ambroxan. If you're making a perfume, I would recommend you just see what happens if you put a little bit of ambroxan. I like it so much that I actually, kind of dilute it in ethyl alcohol, and this is plain ambroxan. It's a very subtle smell, but it's just so beautiful, and it's really one of those molecules that have a very subtle but a very definitive valence effect. And I equate it to some extent kind of like the hedonic tone component of, drinking, I don't know, like a third of a glass of wine. You're not obviously affected, but it's doing something. And I think if you spray ambroxan in an apartment before a party or something like that, people will notice this something strangely clean and soft about the environment, and they're not going to be able to place it unless they're a perfumist, in which case, like, why does your apartment smell like Ambroxan? But yeah, other than that, yeah, it's I recommend it. It's like just such a subtle but almost always uniformly positive alteration to conscious experience. Okay, so that's the Qualia of the day. We're gonna actually get into very serious business today. Really, I mean, actually solve the phenomenal binding problem, like for reals. Okay, so been waiting so long to make this video. Well, number one, what would it mean to solve the problem of consciousness to begin with? Okay, so the hard problem, by David Chalmers, is kind of this very interesting observation that it is very difficult to conceive of a way in which form and structure could give rise to qualia and conscious experience. And as stated, the hard problem is actually conceptually unsolvable. And there's many approaches that people have kind of taken in order to either try to solve it directly or deconstruct it or propose a different framework that is solvable. And an analogy that David Pearce and Mike Johnson, they both like to make, of course I repeat it often, is that talking about the hard problem of consciousness as the problem of consciousness is sort of like talking about the hard problem of matter. Whereas like, no, actually, there's a lot of subcomponents, right? There's like the problems of forces, of particles, of fields, electromagnetism, strong force. The hard problem of matter is really an improper reification. You really should decompose it into a bunch of subproblems that eventually gives rise to, metallurgy and chemistry and so many sub areas. And you really, there's no one hard problem of matter. So following that analogy, I think it makes a lot of sense to talk about the hard problem of consciousness by reframing it into subproblems, subcomponents that can actually be tackled successfully. So, and those are, well, Mike Johnson has a bigger list, the 8 subproblems of consciousness, and I recommend checking it out. I'll have a link in the description. But it's very technical, and it would take us hours and hours actually to dig through them and provide the solutions that we have at Qualia Research Institute for them. But which is why I'm going to be focusing on David Pearce's breakdown, which is that any scientific theory of consciousness must be able to solve and explain, A, why does consciousness exist to begin with? Number 2, what are the qualia values and varieties and their interrelationships? So once again, here is the logo of the Qualia Research Institute. This, in a sense, exemplifies the qualia variety of phenomenal color. And the way in which they're geometrically related is in this Euclidean layout, such that the geometric distance between the points that corresponds to qualia values is proportional to their subjective difference. Now, this is just for phenomenal color. We don't have equivalent maps for every qualia variety and every qualia value. Eventually, we want to have them. But then even if you have those maps, there is the further question of why those in particular? Why is the qualia of color in particular the way it is? And why are they related in that way? Those are perfectly legitimate questions that really deserve an answer. Then we have the binding problem of consciousness, which is what we're going to be focusing on today. Now, of course, they're all interconnected. So actually providing a solution to the phenomenal binding problem will in turn facilitate solving the other problems. And finally, we have the problem of causality. A, how is it possible that natural selection recruited consciousness for information processing purposes or causal effects? And B, how is it possible that we can talk about consciousness? What am I doing right now? I'm trying to talk about, the structure of my subjective experience. How is that possible? In some sense, that rules out at least a wide variety of epiphenomenalisms, which is this claim that consciousness in and of itself doesn't have a causal power. We're gonna dig deep into that because epiphenomenalism is really complicated, and pretty much every theory of consciousness has one or another way in which epiphenomenalism shows up, and it's very non-trivial to actually solve it. Okay, so different theories of consciousness will have different approaches to these problems. Well, I'm going to make an analogy, and that is that solving the problem of consciousness is more or less like solving the problem of how to go to the moon and back. Now, a theory like illusionism, which ultimately says that, well, it's an improper reification. There's really no weird substance that is, qualia or anything of the sort. The way in which they solve the problem of, hey, how do we go to the moon and back, is by saying the moon is an optical illusion. It's not actually there. And that sort of explanation would actually work for example, a rainbow or the halo around the moon. Yes, those are optical phenomena. The rainbow is not actually physically there where you think it is. It is an optical phenomenon. But the moon is there, actually, right? And you can go to the moon, and people in ancient times, they may not have been convinced of that. They may have thought the moon is infinitely far away, or it's a cosmic entity, or indeed, it's just a weird projection. Maybe, the gods are kind of painting the sky, but it's not really there. But now we know the moon is actually there, and is really freaking far. But you can go there. Now, we're not pursuing the illusionist route. I think it's, basically, it's really kind of, there's a sociological component there, which is that, it makes sense to have kind of like very broad brush skepticism around consciousness, because pretty much every solution that has been proposed fails to actually satisfy all of the constraints that a real theory of consciousness ought to satisfy. So, as a matter of priors, that if somebody's proposing a theory of consciousness that is going to satisfy a lot of these constraints, overwhelmingly likely they actually don't have that theory of consciousness, or it doesn't work in one way or another. So postulating illusionism, eliminativism or functionalism ultimately is a way in which you can kind of like take the skeptical stance firmly and not make a fool of yourself by actually taking the problem of consciousness seriously. Yeah. We're not doing that here. We actually are okay making a fool of ourselves because we actually want to solve the problem. And the problem can be solved. So, that said, a very similar kind of like situation that tends to arise is where we have people that dedicate their entirety of their careers thinking about consciousness only in terms of a subset of these sub-problems. For example, they might exclusively think about causality. I would say something like integrated information theory, which now is kind of like trying to develop also a theory of qualia. Yeah, for the most part, most people thinking about IIT are thinking about the causality problem, not necessarily the binding problem or even, why it exists to begin with. It's not really trying to solve all these constraints at once. So with the analogy to going to the moon, it's something like trying to solve only how to achieve escape velocity without taking into account the fact that there is air drag that you have to compensate for. Or, maybe if you are taking into account the air drag, you may think that it extends all the way to the moon, not realizing that actually at some point it becomes a vacuum. In which case you may not be concerned about, building spaceships that are actually airtight. And that's something that you really need to do as well. Okay, so by me formulating these 4 sub-problems of consciousness, or Mike's 8 sub-problems, it is in some sense saying, hey guys, you need to take into account the air drag. You need to take into account the, escape velocity, the angle of re-entry, how you're going to actually land on the moon and get out of the moon again. So, and if you are not holding in your mind all these constraints simultaneously, all of the solutions you come up with are going to be partial. Now, of course, constraint satisfaction problems can be NP hard. So what you have to do to a large extent is focus on some sub-problems, find a partial solution, see if it matches with other sub-problems, and iterate over and over until you find something that, kind of as a equilibrium, consilience points, solves all of them at once. And that can take years and years and years. Again, very arrogantly, I'm going to say, yeah, we kind of have a tentative solution, not a full solution, but something that goes much further than what other people have taken into account. I also want to absolutely, say, if you encounter, the solution to the binding problem that I'm offering in this video anywhere in the literature, please point it out. I have looked and searched and talked to a lot of people in academia and, in AI and neuroscientists. And as far as I know, the solution I will provide is new and original, especially argued in the way in which I'm going to argue it, which is something that solves all these sub problems. So, but I could be wrong. There could be an obscure paper, Lewis 1963, they found exactly the same solution. It's possible. I don't know. But please let me know, I would love to know if there is prior literature saying exactly this. I doubt it, but yeah, I don't want to be mistaken about that. So, okay, so those are like the sub problems. Now let's get into the binding problem more specifically. So there is a set of desiderata. Like, what would a solution to the binding problem require to do? And I think a good breakdown is the following. Like, number one, you have to be able to avoid strong emergence. I don't believe in strong emergence. I don't think that you can, like in the hard problem, you can put form and structure in specific kinds of way and then like, bam, a completely new ontological entity like Qualia appears, that is unphysical. I don't think that is plausible in any way. Second, you have to sidestep the hard problem, either by reformulation or doing something else. And we'll explain how we do that. Third, you have to avoid epiphenomenalism. Again, how is it possible that we can talk about consciousness? Why was it recruited by natural selection? And why is our consciousness actually properly ordered? Like, why is the way in which I talk about my consciousness actually, causally co-varying with the content and the structure of my consciousness? Like, all of that has to be taken into account. And fourth, whatever, solution to the binding problem you provide should ideally be compatible with physicalism. And to remind you, physicalism, what it says is that the laws of physics are causally complete. In a sense, there's causal closure. All of the behavior of what goes on in the universe is accounted for by the laws of physics, or some future iterations of them that actually, I don't know, solve the problem of quantum mechanics and relativity put together. But yeah, essentially future physics standard model gets really close. So let's just say the standard model has to be compatible with the standard model. And if it's not, then yeah, that's a huge red flag. I wouldn't necessarily take seriously a theory of consciousness that introduces completely new laws of physics, or, denies the laws of physics or something like that. So no, we're physicalists at QRI, but not materialists. Materialism is physicalism plus this addendum that says, and by the way, all that exists is matter itself. It's kind of like, that is like an insentient brute component, primitive of reality is like non-sentient matter. So that would be materialism. In some sense, is like a stronger claim. Physicalism is only talking about, form and function and behavior, how things look like from the outside, and can they be predicted by the laws of physics. But it is silent about the intrinsic nature of what is physical. Okay, so that is the desiderata, So I'm going to be reviewing various possible solutions to the binding problem and then showing that they don't really work until we get to our solution, which I think does work. Okay, so the desiderata, a very important kind of like background observation for solving the binding problem. Well, I guess I should really clarify exactly what I mean by the binding problem. So it's, okay, if you assume that the world is made of particles and forces between those particles, how is it possible that 100 billion neurons, distributed spatially in a brain, or an entire body, if you're kind of like an embodied cognition type of person or embodied consciousness type of person, how is it possible that something that is spatially distributed, involving so many particles, somehow comes together to not only behave as a unit, but actually instantiate something that is unitary, i.e. your moment of experience? Every moment of experience contains multiple pieces of information at once. Now, one way in which some philosophers dismiss the phenomenal binding problem is by saying that our consciousness is actually less unified than it seems. And, that is all well and good. I am very willing to accept that, in fact, a lot of the unity of consciousness is somewhat illusory. And yeah, if you get very advanced in insight meditation, that becomes really obvious, that we kind of like draw illusory connections between things, and in some sense we think there's more information there than it really is. But there's a fallacy there when it comes to extending that observation into saying that, hey, the binding problem is not a problem at all. Because even if there is any unification whatsoever, like, if you have like an experience that contains 2 bits of information at once, that already presents the same, it's a very, very deep problem already. I mean, let alone, the complex and rich textures of experience that we're acquainted, with on everyday life, or even crazier things like super states of consciousness, like 5-MeO DMT, where there's so much energy, intensity of consciousness, all of it bound in each moment of experience. So what is going on with that? In some sense, yeah, it doesn't matter how little the unification is, as long as it's non-zero, the binding problem is still a real problem, okay? And I think a lot of the illusionist aesthetic is actually on, I can't help but notice, some people pointed out that I look a little bit like a magician or something, so an illusionist, but not about consciousness. So yeah, so one way in which you can potentially kind of like see clear, why the binding problem is like such a bizarre thing, indeed such an existential puzzle, is that where does the observer come from, right? If you have only particles and they're interrelated with forces, how do they clump together in order to interact as a unit and be a unit with other particles? In fact, if you have an assembly of particles, there's really no principled way of drawing boundaries between them and say, this subsystem and this subsystem are in some sense observing each other. Okay, so you have a very, very, very fundamental bootstrapping problem. That if you're talking about, hey, the binding problem is, well, all these neurons are creating these interrelated patterns and high-level structures. Yes, but how do those structures observe themselves? They can't, because themselves are made of those particles, right? There's no way of bootstrapping larger structures unless you shift to a different kind of ontology. And one way of talking about the binding problem that actually does advance, a possible solution conceptually is by reformulating as the boundary problem. Okay, so this is a shift in ontology. Standard kind of perception of kind of like classical information processing is, yeah, the world is made of particles and forces. And to a best to a first approximation, that's it. Of course, there's quantum mechanics, but quantum mechanics really doesn't have like obvious, kind of macroscopic effects. So probably, quantum mechanics is actually not involved in consciousness. So let's go with particles. Okay. So in that universe, there's particles and there's, interactions between them. Well, if you start out in a very different ontology where you say like, no, actually reality is made of fields. And for sure, quantum field theory, but not even just quantum field theory. Electromagnetism is a theory of fields and particles, but also fields. So you do have as building blocks of reality fields, okay? Then the question becomes, well, if everything is a field, it's kind of like unified to begin with as by default. Then the question becomes, how do boundaries arise within those fields? And I think actually that is a much more promising way of thinking about this. And I will point out, that when you're talking about this problem, overwhelmingly nowadays in the zeitgeist, people will say, yeah, well, I mean, to a first approximation is just particles, right? Like quantum mechanics, like you would have to show kind of like femtosecond level, computation going on in the brain, which is, yeah, quite unlikely. But it's a false dichotomy. It's not classical physics versus quantum computing. You actually have field dynamics, macroscopic field dynamics with electromagnetism. And then they ask like, well, but what tells you possibly, that consciousness has any kind of like field quality? And is actually so much. There's so much that indicates field behavior in your consciousness. And I'm going to go deeper into that. But I mean, if you notice on meditation, for example, how different components of your experience can enter in sync with one another, it feels like there is resonance between fields going on. Quite similarly to how, for example, a string in a piano, or let's say a guitar, it has this holistic behavior that it moves all at once. I mean, it's not like, moving faster than light or anything of the sort, but you do have a holistic field behavior. And if you pay attention to your experience, you will notice holistic field behavior everywhere, especially in exotic states of consciousness. When you take a psychedelic and you experience, crazy things like these, or, wallpaper symmetry groups and so on. Whenever you experience symmetries, a wallpaper symmetry on the visual field, it will behave as a unit. It actually kind of like starts to form and then it clicks into place. And I would say that behavior is the same kind of holistic field behavior that you have when you pluck a guitar string. That yes, at the very beginning, you have a wave propagating, and that looks like, oh, it's not very holistic. But after a little bit, the only frequencies that survive are those that can fit an integer number of times in the string. And at that point, it actually starts to behave like a unit. And in that sense, yeah, that would be an example of what we call holistic field behavior. And yeah, I mean, if you pay attention to consciousness, if you pay attention to psychophysics, so many perceptual effects, like the Candy's illusions, like those, 3 Pac-Mans that create an illusory triangle. I've got a book right there, Conscious Mind, Resonant Brain by Grossberg. Anyway, there's Stephen Lehar has like done a lot of research on these. There is a ton of evidence that suggests that conscious perception is field-like. In some sense, actually, the particle-like nature of experience is an exception. Like only when you have kind of attentional pinches, things that are kind of like really, I don't know, like something that is like really itching in a part of your body, generating these like tiny pinches. Yeah, that's kind of like particle-like. But you introspect in how it's affecting the rest of your experience, it actually feels much more like waves of energy are bouncing off those particle-like pinches. But actually, most of your experience is made of this, what feels like waves of energy bouncing around. All of that would be field behavior. And yes, I take very seriously electromagnetic theories of consciousness for that reason. And likewise, I mean, if you look at brainwaves, brainwaves are macroscopic oscillations of the electromagnetic field. They are used routinely, for diagnosing diseases and, biofeedback. Yeah, they're macroscopic. And yes, that would be a holistic field behavior effect. Again, kind of thinking about it in terms of fields is so much more generative, and actually I would say so much more correct, so much more, so much closer to the actual phenomenon and the properties of the phenomenon that we're studying, especially so if you actually take seriously exotic states of consciousness where nothing, nothing on a high dose of LSD makes sense except in light of field behavior. Like nothing. Pretty much everything that happens in a high dose of LSD is crazy field interactions. We're gonna get back to that. Okay, so I think the reformulation of the binding problem as the boundary problem actually is very generative, and not every solution does that, but I think only solutions that do it have any chance whatsoever of actually solving this problem. So let's go through the list. And the list is, let's start with cellular automata. Okay, so some people, it's a common belief as far as I can tell. I remember in college somebody was saying, like, oh, don't you believe that a glider, like a glider is conscious? Like, you know, maybe minimally conscious. Yeah, but, okay, so what defines the boundary of a glider? So here's exactly the problem I was talking about, which is, how do you bootstrap an observer? It's like, okay, us as a conscious entity that is looking at the cellular automata, we can say, oh yeah, you know, the glider kind of forms a natural functional unit, but the glider doesn't see itself. You know, to presume that a glider is conscious, you actually requires to postulate this very weird thing, which would be a kind of like extra dimensional reality compiler, some kind of like God entity that is like looking at the cellular automata of reality and saying like, oh yeah, this kind of looks like an integrated pattern. Let's give it a stamp of approval and, you know, give it a soul or something like that. Because if you don't have that, you know, if you're actually just looking at what is truly going on in the cellular automata, there is no glider. There is just black and white squares flickering. That's all. You know, maybe if you consider the entire grid, the entire lattice as, you know, a unified entity, like that could be unified. But otherwise, you're going to be stuck with, you know, having each cell being its own being at best. In which case, yeah, a glider is not like all of a sudden generating a new being. That's an illusion. It's an illusion because we have the capacity for parsing visual data and extracting things that are like more or less functionally unitary. And in that sense, yes, gliders are kind of a thing. They're a thingy. You know, they have some thinginess to them. But no, for sure, they are not natural units in any form whatsoever. It's illusory. Okay. Maybe to be a little bit dramatic, we can cross off cellular automata. Okay, I'm not trying to be offensive or trying to be mean, but cellular automatas, no, they're not a very plausible solution. Okay, now complexity. Yeah, I mean, some people seriously say, oh, it's just a matter of complexity. When you have enough complexity in a system, all of a sudden you have this kind of like unity. But complexity is ill-defined. In fact, there's like a gazillion different definitions for what complexity might be. And none of them gives you kind of these nice, none of them in a principled way can actually solve the bootstrapping problem. Or it gives you kind of like this necessary discontinuity to say, well, here is the boundary around this complex phenomena. Unless you define it that way. But then it's kind of like something that you are defining. I mean, if you kind of like set a criteria for this and this and this is the criteria for a minimally complex conscious entity, again, that's in your mind. That is like you looking at the cellular automata and saying, oh, this glider, it kind of looks like it meets a minimum criteria, but it's not actually doing anything at the ontological level, okay? And you do require some kind of like modification to the ontological substrate of reality in order to create actual new beings, new moments of experience. Again, this sounds completely impossible to do, especially with the criteria laid out, which is a very harsh criteria, like, you know, avoid strong emergence, gliders being conscious, or complexity giving rise to consciousness, and unity of experience. That would be strong emergence. So it fails that criteria. Believe it or not, our solution actually satisfies the avoiding strong emergence, and hopefully you'll see it in a second. But okay, complexity is off the list. Synchrony. You know, this actually has quite a bit of neuroscientific backing, that synchrony in the nervous system is associated with local binding. Here's an important piece of vocabulary. There is global binding, which is any two, quale in your experience. The fact that they belong to the same experience means that they are globally bound. Local binding means that the features of your experience are actually connected in such a way that they generate a coherent percept within your experience. So here, for example, color and shape are locally bound. You see, this color green is not locally bound to my eyes. You're not seeing green eyes. But it is locally bound to the frame of these glasses. Now, this kind of binding can actually break down. There are some people with specific kinds of brain damage that they would not be able to tell which, they will be able to tell there is green in the scene, but they will not be able to tell to what it belongs. And on LSD, for example, you will see kind of like this drifting effect where the green kind of like sometimes belongs to the frame and sometimes belongs to something else. There is kind of this dislodging of local binding. The local binding connections become unstable and kind of you get like exotic binding around it. So, well, that is local binding. And synchrony empirically does seem to be very, very, very tightly related to local binding. In that, when you have synchrony between, for example, certain area in your visual cortex that has been identified with, for example, color perception, and some other part of the visual cortex that has been identified with shape perception, when they are actually in synchrony, that usually will mean that they are locally binding those features. But, this is an empirical observation. But why would synchrony actually solve the binding problem? I mean, to begin with, it doesn't solve the global binding problem. There's a lot of stuff that belong to the same experience that are not in synchrony in your brain. So right off the bat, empirically, it doesn't work. But even if you were to say, well, maybe it is kind of like synchrony in a different way, maybe coherence, there's many kind of like additional definitions and statistical constructs, some of them more plausible than others. Coherence is a very important neuroscientific concept. It's a generalization of synchrony. Why that cannot be the case? Well, because it is not frame invariant. And in that sense, it would actually be incompatible with physicalism. So here's the thing. Whether two neurons are activated at the same time depends on your frame of reference. And actually, like what is at the same time with a given neuron will depend on which neuron you're looking at and its movement. Well, they're not moving very much, but you will require to localize them. And there's no universal plane of simultaneity. We know that from relativity. So actually there is no matter-of-fact ground truth about what is in synchrony with what else. So I'm sorry, synchrony is not a brute fact of reality. So it's not going to solve the binding problem. But it is a very important hint. And actually, we will come back to what is synchrony doing in our solution. And synchrony is very relevant, but it's not ontologically fundamental. And yeah, in that sense, it's not a solution. I'm sorry. So synchrony gets removed from the list. Okay, integrated information. Oh gosh. Well, integrated information, Giulio Tononi and their lab, they're doing fantastic work. I mean, the thing that I really admire about integrated information theory is that they are, in some sense, the first movers for a Qualia formalist account of consciousness, meaning that they actually take very seriously the idea that you can translate a physical system into a mathematical object and then, in some sense, read off what is going on in the conscious experience of that system by looking at the mathematical features of the mathematical object that is isomorphic to it. So IIT, fantastic. It is exploring that. But the devil is in the details. I would say if you actually look at the specifics of the math of IIT, there are strong reasons to be skeptical that that is actually something that will work out. In particular, I do have what I think is a silver bullet critique of IIT having to do with, basically their postulate number 4 of how they defined this thing called the minimal information partition. This is all unfortunately quite technical. It might take us longer, but just to give you the gist of it, they have this claim that when you're analyzing a system and you're computing the integrated information of each of the partitions of that system, essentially what they call the information partitions, they say that you look at all of them, and then the largest one has, in the words of Giulio Tononi, the highest claim of existence, and therefore it is the one thing that is conscious in that system. There's a lot of problems with that, but the biggest, most glaring problem is that it makes consciousness epiphenomenal. Actually, right? Because, and it's crazy because the whole point of IIT is to reduce consciousness to, in some sense, irreducible causality, integrated causality. But when you say, well, yes, there's all of these integrated subsystems, but I'm only going to say that the largest one is the one that is conscious because it has the highest claim of existence. That is in your mind. That's in your brain. It's like the glider thing. It is not actually doing any further causal effects. It's not like, it's very different like in physics. You see, in physics, what's called the, extrema principles, that you can tell essentially where a photon will travel by looking at what is, in some sense, the least action, the shortest path, and so on. That is not epiphenomenal. So what you do is, if you want to compute that, is like, for example, where an electron will travel, is you assume that the electron, this is the path integral formulation by Feynman, you assume that the electron travels through every possible path, absolutely every possible path, and it's interacting with itself in every possible way. And then you add up the amplitudes and the phases of all of them, and it will turn out that almost all of them will cancel out. And only those that have like very similar trajectories essentially have enough amplitude to actually make a dent or a difference. So the minimal path for an electron is not epiphenomenal because every other path is canceling each other out. And that is a causal effect. Whereas in IIT, the minimal information partition is not canceling every other partition. And therefore, it is epiphenomenal. It is like a glider. It is you projecting it into that system. It's not actually doing any computational legwork. So it couldn't even be recruited by natural selection as is. Now, I do have hope for, a future version of IIT actually, going somewhere deeper. But for the time being, in its formulation, it's not going to solve the binding problem because it's epiphenomenal. Yeah, so, okay. So integrated information is not it. How about causality? Okay, so some people may try to explain the binding problem in terms of irreducible causality, very similar to IIT. Now, consider this. When you have, just random objects here. When you have like, I don't know if I can do this, but when you have like one object, this is like a dominoes, imagine, right? Like, okay, this one falls, and then this one falls. Okay, you can trace back exactly, okay, this one is the one that made this one fall, which is the one that made this one fall. Okay, fine. But what if you have both of these, in a sense, because this one is very heavy, let's say you have both of them fall at once. In some sense, you have kind of some sense of irreducible, causal effects where A and B need to put pressure on C simultaneously for C to move because it's very heavy, So that could be an approach. You're saying that, consciousness is when you have these assemblies of causal structures such that you need all of them at once in order to affect the change that you observe in the world. So that is promising, but we have two problems with that. A, again, lack of frame invariance, that exactly what caused what is something that when you're talking about integrated causality, you have the problem of simultaneity, and it's not clear that you will be able to say, A and B were actually simultaneously putting pressure on C for it to move. That might be possible to solve with some tricks, perhaps. But the deeper problem is that now you don't have a boundary in time. So maybe you're solving a bit of a kind of a boundary in space with integrated causality, but I don't think you can solve a boundary in time. How do you draw that boundary? A and B sure are affecting the change in C, but C moving is not a natural kind. There's no sharp discontinuity actually in physics when that is happening. And in that sense, it's not a true solution. Everything is causing everything else in the universe. You right now, you are the result of the entire backward light cone, all the way from the Big Bang, which involves a huge number of galaxies and black holes colliding and enormous processes. I mean, in some sense, you are deeply connected with that, but are you irreducibly that entire light cone? No, you're a much, much, much smaller part of reality than that. Your consciousness doesn't have, in some sense, all of that information explicitly there. Maybe implicitly, but then, yeah, we get into some issues there. But yeah, anyway, causality has the problem that there are no boundaries in the time direction. So we can rule it out as well. How about spatial proximity? I mean, this is a very bad one, but that is a very, very important question. Like, why my left hemisphere and my right hemisphere are simultaneously contributing to one experience, but not my hemisphere and your hemisphere? Even if we're in the same room, why are they not simultaneously contributing to, let's say, the same visual field? And somebody might say, well, spatial proximity, they're just closer. But, you could do brain surgery and just, squish your brain to mine without adding connections. And I don't think that would actually generate just one entity, so I think like spatial proximity is totally a red herring. And yeah, I mean, credit where credit is due. A lot of functionalists actually deeply, deeply get this. I mean, people who believe that a Turing machine can be conscious rightfully, understand that spatial distance is not, unnecessary. Things can be very far apart and still contribute to the same experience. I do believe that. Very similar to that view is kind of like the number of connections, and IIT would say something like that like, hey, the left and right hemisphere have a lot of connections, whereas my brain and your brain doesn't. But again, that is not a hard boundary, because even if we're just in the same room, we are still causally connected. Less so, but the difference between my experience and your experience actually seems to have a hard boundary. We are different experiences, and it's not a matter of degree. It's not like we are like kind of blended. We're strictly different experiences. So yeah, spatial proximity and kind of like a coefficient of, causal interrelationship, they're not going to work as full solutions. Behavioral coherence is like another thing that people talk about, and I also think it doesn't work. That tends to conflate, essentially, it conflates behavioral or functional unity with ontological unity. So just because an organism is behaving as if there was a kind of like unitary subject driving it, it doesn't mean that there is a unitary subject driving it. Why? Because it could be a lookup table. In the worst case scenario, rather than a nervous system, you could actually have a lookup table. It could behave as if it was, unified in a coherent way without actually being so. So yeah, behavioral coherence is not a solution to the binding problem in the least. The Mach principle, I mean, this is a very niche theory. It would be by Ken Moji, the Sony Qualia guy, which I really like, and I really love his book on Ikigai, and that he takes these ideas very seriously. And he has a attempted solution to the binding problem, which is essentially this idea that, a photon that goes from one star to another, it may take from an external observer, millions of years, but from the frame of reference of the photon itself, it's instantaneous. So in some sense, like binding across time can be done with things that travel at the speed of light. And in some sense, how different paths of things that are moving at that speed coalesce, in a sense, is capable of binding things that are distributed across time, and in that sense create internally complex unitary states. I don't think it works for the same reason that causality or integrated causality doesn't work, which is that there is no boundary across time. So by the Mach principle as well, we would be exactly in the same moment in a way as the Big Bang, unless you actually count each moment as each interaction. But then in physics, most interactions are actually going to be just particles colliding with each other. So that's not enough information for a full conscious experience. So, and the moment we're talking about neuron, like something at the level of neurons, I think the Mach principle, just kind of like out the window, unfortunately. So yeah, I don't think, but I do really like that as kind of a very creative approach, and it's very novel as far as I can tell. Okay, the two last ones, one is very close, and then the last one is actually, I think, the solution, is resonance. Like number 9 is resonance, and Stephen Lehar talks about that. And again, let's say you took LSD and you're seeing your visual field tessellate. There is resonance between the various components of your visual field. And actually, I mean, something that we have pointed out at QRI, I don't believe others have, figured this out when it comes to explaining meditation effects, psychedelic effects, is that there is a kind of duality between temporal synchrony and spatial symmetry. That when you actually experience something symmetrical, perfectly symmetrical in your visual field, that entails that there is harmonic resonant waves that are actually synchronized. And so like temporal synchronization and spatial symmetry come together. So there is this, kind of like interesting revival of, hey, resonance and synchrony are very, very related as a possible solution to the binding problem. But what makes resonance especially tempting as a possible solution to the binding problem is that it gives you functional unity for free. So essentially, when you have a system where A is resonant with B, which is resonance with C, you will have some degree of functional transitivity, where the entire system will behave as a unit. And in fact, when you have two things that are in resonance across the dimensions of resonance, if you modify one, you will see that modification be reflected in the other. Not instantaneously, because nothing travels faster than the speed of light, and definitely not acoustic vibrations or mechanical vibrations of resonance. So forget it. This is not an instantaneous thing, but it can be fairly fast. It depends on the frequencies of oscillations. But if the frequency of oscillation is really fast, it essentially, functionally, works as a glue. So things that are in a state of resonance are functionally glued together. It actually works as a force. It actually forces if it was kind of a rigid tube that was connecting these components. And I think that's the case with our experience. Actually, the components of our experience that are in a local binding connection are such that if you move one of them, the other moves as well. So again, when I move the subject, I mean, the fact that you're binding these colors to these particular shapes and to the overall construct of the Megumin's cube, or Rubik's cube, they're actually in a state of resonance with each other. I do believe that. I think you can confirm that in the lab in a number of ways. And that form of resonance is actually allowing you to very quickly, in a cross-model fashion, compute where the entirety of the object is located and what is the angle in which you're seeing it. So yeah, resonance actually makes the job of perception a lot easier because the things that are meant to be connected with each other are properly connected. Again, on an altered state of consciousness that can break down. and you can have resonance between features of an experience that are not actually bound together in the world, or really like there's any sense to do it in your mind. So for example, you may experience kind of like resonance between my eyes and maybe an object behind. They may create like a asymmetrical or like a vortex type pattern. If you're on LSD watching this, that will behave as a unit, and it will have kind of this glue property. But it's in a sense a maladaptive perception, you know, because there's not actually anything in the physical world that is connecting them at that level, you know. Yeah, I mean, I think like resonance in, you know, the field of awareness is very obviously there, especially once you dig into psychophysics and visual illusions, and what happens on meditation and psychedelics. Resonance is all over the place. It's very, very stunning that that's not like, you know, currently that big of a component of modern neuroscience. So the problem though with resonance is that even though it kind of solves the binding problem, it's like, okay, how does these components of reality, how are they in some sense connected to each other? It doesn't solve the boundary problem. Why? Because just because two things are in a state of resonance doesn't draw a natural boundary around them. You know, you still need kind of this mythical compiler that looks at the system and says, oh yeah, this and this and this and this are in resonance, so therefore let's kind of consider a unit. But again, that would be kind of the glider operation. It's like something you're hallucinating, you're projecting into the world that is not necessarily there. So what is actually going on here? I think actually the same, like, as far as I know, this problem comes up with every theorist who proposes, for example, electromagnetic theories of consciousness, for example, the semi-field by McFadden, or Susan Pocket identifies consciousness with local field potentials. I think the case is really strong that there is something really there. Just to give you the gist of it, it seems that there's a lot of unconscious processes in the brain. There's actually a lot of neural activity that doesn't generate conscious experiences, doesn't paint any qualia on your experience. And those that do seem to be precisely those that generate local field potentials. And as Stephen Lehar would say, you know, most neuron activity is kind of like sandblasting the fields of electromagnetism. And actually your experience is, you know, those local field potentials stitched together into this crazy, you know, pattern of competing clusters of coherence that are in a state of global resonance, or, you know, interconnected resonance. But local field potentials don't have an obvious boundary, or at least you need more than just say that, okay, local field potentials solve the binding problem. You have still the boundary problem. So how do we actually solve it? Here's the solution, guys. Here it is for all of you. So the solution is topological segmentation. So if you imagine that, yes, well, here is roughly the solution. So first of all, we started with a panpsychist account. Actually, you know, what exists is the fields of physics, and they are fields of qualia. Okay, if you're not on board with that, there's not much we can do. I can, you know, tell you, I've searched through all possible, you know, at least humanly conceivable theories of reality, and this is what seems to make the most sense and satisfy as many of the constraints that we have as possible. So imagine the fields of physics are actually qualia, and they start out unified. So in some sense, the entirety of the fields of physics start out as a kind of natural unit, a super experience in a way, but not a mind. It's not an intelligent experience for the most part. That doesn't arise automatically. You actually need a very complex process of natural selection in order to select intelligent patterns that are good at information processing for survival and so on. But the entire field, here with an analogy to the balloon, is made of qualia. Let's say this yellow qualia. Well, maybe not. A topological segmentation is something that can arise naturally as direct effect of the laws of physics without introducing new clauses. If you twist a balloon like this, yeah, at some point it collapses. It forms a pinch point that actually generates a global boundary. You see, and we can define a global boundary as being essentially that if you're in one point in one of these fields, for you to go to another point in the other field, you need to go through the pinch point. So because of that necessity that you have to go through the pinch point, that makes it a global boundary. Alternatively, a local boundary would be, for example, if I do this, you see it pinches kind of the balloon in this way, meaning that, or even like this, you know, kind of like in between, meaning that from any point in this field to any other point, you have the option of going through that pinch point, but it's not necessary. You're not required, you're not forced to go through that. So that would be a local boundary. And what I'm going to suggest is that local binding is actually generated by these local boundaries. And global binding is actually the result of global boundaries. Okay, so let me paint this picture more closely. So there's a wonderful, super classic book about valence. No, it's not emotional valence. This is chemical valence, but not the same. I mean, okay, how do molecules get formed? How do you get bonding? You know, molecular bonding. So that's been a very big area of research for obviously many years, and you know, you started out with kind of like these very simple rules, what's called, for example, the Lewis rules of molecular binding. It's like, well, you know, you have the orbitals and you have like the octet rule, and that is kind of like the rule that makes it happen. But it seems kind of like very, very top down, like, well, where do those laws come from, right? Like it's not obvious that should be the case. Instead, if you start out with the fields of physics, actually, you know, in quantum mechanics, the Schrodinger equation, and assume that, yes, actually the behavior of reality is ruled by the Schrodinger equation and it's actually a bunch of fields, then you can derive Lewis rules as a good approximation to that. But it doesn't always work. And actually, there's all sorts of crazy exceptions. For example, pi bonds. This case, you know, when you have like these weird orbitals that arise when you have, orbitals of the same polarity right next to each other, or the pi electron of aromatic molecules. Very crazy stuff that looks like strong emergence. And it would be strong emergence if you had only an ontology of particles and forces. The pi electron would be a strongly emergent thing. It would arise really kind of out of nothing, out of like, it would be like a new law that you have to invent, the pi electron law. But if you have a fields of physics ontology and the Schrodinger equation, the pi electron arises totally naturally. It's just there. It's like it's a necessary consequence of that ontology. And also a beautiful thing about chemistry is that the actual orbitals that do arise and the resonant modes of a molecule are precisely of the holistic field behavior kind. In other words, they are these fixed points of possible resonant modes of all of the components of the molecule simultaneously. In other words, are the fixed points of the dynamic system. And as such, in order to derive what they are, you actually require to take into account the entire object simultaneously. So, and this is not something that would arise actually naturally from just, you know, point particles. It's an inherently field-like behavior that molecules behave as units. Now, just because they behave as units doesn't make them units, okay? But imagine, and this is something that I don't know for sure, you know, but it's for the sake of illustration, that when you have like orbitals like that, you actually have a topological boundary arise. Now, if that is the case, which I'm not claiming is the case, this is an example, but assuming it is the case, then you have this beautiful correspondence between the creation of a new being, a new segment that has a natural boundary, and something that behaves as a unit. So that is the marriage between an ontological emergence, not strong emergence, because you're not applying new laws out of the blue, but it is an ontological emergence. It's the emergence of a new being, a new segment of the universe, and functional unity. So all of a sudden, this new object, this new segment, behaves as a unit. Now, with quantum orbitals, I would say that's still very much an open question. When it comes to like macroscopic objects like this, it is absolutely the case that you have kind of a holistic behavior emerge. So by me creating this pinch point, and if I make this vibrate very fast, you will see in a sense that because of this pinch point, this entire surface will have its own resonant modes. And it will behave as kind of like a unit, a subcomponent. And you actually require that for a lot of things in physics. For example, here, this is not strong emergence. This is like soapy water. These bubbles, they are, on some sense, if you want to analyze this at the macroscopic level and simulate it, you actually, if you're in graphics or something like that, you require some kind of topological engine that tells you, okay, which face is connected to which face, at what intersection, are there 3 or 4 faces intersecting in one single point, do they share the same plane? There's so many like topological considerations, and mathematically speaking, this would be what's called a CW complex, because you have essentially surfaces of different dimensions. You have like 2D surfaces, lines and points, and the entire system and its behavior actually really is predicated on the topological structure that arises. So when you have like a phase of like one of these bubbles and you make it vibrate, you will have to actually look at that segment and its resonant modes, and it will behave somewhat like a unit. Not 100% like a unit, because it's still connected to the rest of the structure, but it will have its individual harmonic resonant modes. So what I'm claiming is that the brain is such that its resonant modes actually pinch the electromagnetic field and generates these topological pockets. And the reason why that was selected by natural selection, that why that can be, in a sense, useful for an organism, is because by pinching the electromagnetic field in that way, all of a sudden you have the resonant modes of that pinch, which is holistic field behavior, something that you can actually use for computation. So let's revise. We avoid strong emergence because we're just using the laws of physics, and these topological segmentations are natural. I mean, like the bubbles, you don't require a new law. However, you do get this ontological new structure, this new segment of the universe. 2, we sidestep the hard problem entirely via panpsychism. Essentially, and this is obviously a rabbit hole, but for example, David Chalmers has this paper called The Combination Problem for Panpsychists. He explains how, yes, panpsychism overcomes some problems with the hard problem, but all of a sudden you have that there's no natural boundaries. But as a response to that paper, I'm going to say topological boundaries can be a wonderful candidate in this case to actually solve the combination problem for panpsychism. Number 3, you avoid epiphenomenalism. Why? Again, because by generating these topological boundaries, you segment the wave function in such a way that you get holistic field behavior. You actually get things behaving as a unit, and that can be used for computational and causal purposes. So it's not epiphenomenal. Your consciousness and the boundaries of your consciousness are actually relevant because they define what is going to have a harmonic resonant modes. So epiphenomenalism, we are sidestepping it, which is wonderful. And finally, compatible with physicalism. Now, I'm not going to say I have the equations that show that, the connectum specific harmonic waves of the brain actually generate topological pinches in the electromagnetic field. No, I don't have that yet. But I will tell you that topological structures in the electromagnetic field are routine. They are all over the place. Actually, you're not going to find them in physics textbooks described that way. But if you look up for cohomology of the electromagnetic field, you will see a vast literature specifically about that, which actually looks into, for example, things like Hopf's bifurcation, where regions of the electromagnetic field generate pockets where the field lines get trapped. And because, electromagnetic fields are inherently three-dimensional, these pockets are non-trivial. I mean, sometimes they're kind of these eddies, but they're not eddies in the standard sense, like, eddies of water or something like that. They're topological eddies. And even an antenna wouldn't actually be able to propagate signals very far if it didn't do a topological twist that actually generates these topological eddies. So topological segmentation in the fields of physics are routine. They're all over the place. It's a sort of thing that, advanced physicists have to take into account for modeling physical behavior. So, while I'm not saying that I have the equations, I am saying that so far the story is completely compatible with physicalism, and I think we just need to do the legwork, the mathematical legwork, to precisely identify what specific aspect of the cohomology of the electromagnetic field gets affected by neural activity. And with that, that's going to completely close the problem, and we will have actually the full solution. And I'm very excited. I think it's possible. I think it's 100% within reach, definitely within our lifetimes. Okay, so I think I'm just going to finish off with kind of some interesting implications for these. So these may sound trivial, right? It's like, okay, what can you really do with local boundaries? And that's not an experience, a full experience. Well, I take very seriously that, the holistic field behavior of our experience uses properties of the electromagnetic field in a sense for causal effects that manifest or project into Qualia space. For example, when you feel very tense, I know this sounds maybe ridiculous to some people, but no, seriously, when you're in a state of your kidney hurts or you have back pain or something like that, people say the field of their awareness feels knotted or something like that. And that might be something like this. You kind of self-intersect a little bit, and this is tense. So if you were to analyze the, differential geometry properties of the fields, you would say, wow, actually around here in my back or in the somatosensory part of my cortex that represents my back, you see a lot of divergence and curl, which are these differential geometry properties of the electromagnetic field. And they affect each other in a very, very non-trivial way. Again, so maybe this is kind of back pain, or lots of pinches would be kind of a different type of pain. Being completely relaxed, or kind of 5-MeO DMT is you're getting rid of all of your internal boundaries, and you have this smooth, very smooth field of awareness. But what else? Well, actually, the ways in which the field could self-intersect and generate these CW complexes is vast. I think there's a huge number of possibilities. So here's the first kind of non-trivial example. You can knot yourself. And if you knot yourself from the point of view of the surface of this field, this is very bizarre, right? It's you have the field is self-intersecting here, so it shares a boundary, and also around here. And if we were to unfold it, it would be this weird thing. It's not only that you get kind of this paint, it's actually kind of like a wormhole. And that's another of the crazy things. You see, I have kind of a huge rant in here, but when people try to dismiss the profundity of DMT experiences, they say something like, oh, that's just your overexcited visual cortex. We know all of that, edge detectors and motion detectors and something like that. They're trivializing it, which is no, actually, what DMT does is it generates a gazillion number of local binding connections, and local binding connections across your experiential field which is actually much more like this. You're knotting, you're creating these knots in your experiential field that are like wormholes. When you have local binding connections between components of your experience, it's kind of like there's wormholes between them. Essentially, the attention field lines teleport from one place to the other. So a DMT experience, it's kind of like your visual field becomes something intricate like this weird accordion-like complex topological shape. It's so much more profound and so much deeper of an alteration than merely overexciting your visual cortex. It's like, no. You're just trivializing. No, you're not actually paying attention to the phenomena. You have to look at it. Look at it, pay attention. Okay, another non-trivial thing. Okay, a little bit more non-trivial. You know, you can like maybe do a double twist. And again, you're making these crazy wormholes of local binding connections within your own experience. Or maybe even more crazy. You have multiple topologically segmented out surfaces or, you know, complexes in your experience. What is this? This could be a dissociative identity. You know, you did an unfortunate twist somewhere that actually created two topological surfaces within your brain. And all of a sudden, you're actually there's two subjects of experience in your brain. And maybe one of these inflates a lot and the other one deflates. So, you know, one personality is mostly active and the other one is mostly dormant. And they maybe kind of like flip-flop. But yeah, I mean, some of the craziest things that happen in brains is like multiple personalities, dissociative disorders, and it's very bizarre. But I think like topologically segmenting of the electromagnetic fields may actually show. And eventually, if we can visualize that in a person's brain, we might be able to say like, oh yeah, here is Jerome, and this other topological cross-section, yeah, that's Alice. Ooh, their valence is not very good, or the surface that they share is like not particularly good. Okay, let's do a topological boundary surgeries to fix the relationship between the various sub-personalities of the brain. So, and yes, I mean, don't take this, you know, too seriously, but like in the most mystical way possible. Something like Niroda Samapati or high-dose 5-MeO DMT, maybe, I mean, this is very speculative, but maybe it is like, yes, if this is your experience, you know, you're a topological segment of the electromagnetic field, maybe if you relax everything to such a deep extent, all of the fields become parallel, and you actually undo that pinch, and you literally reunify yourself with the rest of the cosmos. Kind of feels like that. That's kind of what a high-dose 5-MeO DMT experience feels like, but, you know, it also might be completely compatible with just the elimination of internal boundaries. So it feels like you're merging with the rest of the universe, but maybe you're still topologically segmented out. I am agnostic. I think it's more likely the second one, but I don't know. Some of those experiences feel so extreme that, yeah, maybe. And that connects finally with, basically Bernardo Kastrup talking about dissociated identities from the cosmos, where like the cosmos is actually just one being and we're dissociated selves of it. And yeah, maybe we're actually dissociated through a topological pinch. And on psychedelics, you know, you maybe kind of undo some of those pinches. Again, very speculative. But yeah, I mean, the topological approach may actually tell us how that dissociation happens, not only that it happens, as obviously it is the case. And with that, I mean, you made it till the end. Congratulations. Anyway, I'll be doing a more, you know, technical write-up about these, but I just wanted to share. That's the solution to the phenomenal binding problem. Go wild. Hopefully this clarified something and you found it valuable. So, well, thank you so much. Infinite bliss, and have a wonderful, wonderful time wherever you may be. All right, take care.